Okay, here's an equilibrium problem. Researcher, in order to study hydrogen halide decomposition, researcher fills an evacuated 3-liter flask with 0.3 moles of HCl gas, allows it to reach equilibrium at 500 degrees Celsius, and gets two HCl's in equilibrium with H2 and Cl2 gas. Equilibrium, the researcher measures the concentration of HCl to be 0.067 molarity. Calculate the concentration, calculate the equilibrium constant in terms of concentration. First thing we need to do is set up an ice chart. So we're going to write here 2. I want to do it in black. We're going to write 2 HCl, and it's gas. It's all gas phase. I'm not going to write the G for gas. Let's just understand that it's in the gas phase. Is in equilibrium with H2 gas plus Cl2 gas. I don't like the way that L looks. The L's are not supposed to have a tail on them. Cl2 gas. We make our ice chart. Boom. Boom. I, C, E. Okay. And this is supposed to be the initial concentration. It's going to be 0.300 moles over 3.00 liters. The 0.100 moles per liter, which is 0.1 molarity. So 0.100 molarity. And it says we fill an evacuated flask. That means it had nothing but the HCl in it. So the starting concentration of this is exactly 0 and exactly 0. That means this is going to become, it's going to initially going to break down and go this way. And we're going to have minus 2x here, plus x here, and plus x here, because of the invisible understood 1 coefficient, visible understood 1 coefficient, and the explicit 2 coefficient here. And it's a minus 2x because we started with 0.1 molarity here, nothing here, so it has to be decomposing. If it is decomposing, that means it's a minus sign. And then at equilibrium, this is measured to be 0.067 molarity. This will be x, and this will be x. And the equilibrium constant will be equal to the concentration of H2 at equilibrium. I'm just going to put the E here to make it explicit, to remind us that we're talking at equilibrium. Excuse me, that 2 is supposed to be on the outside. Okay, at equilibrium, divided by the HCl concentration at equilibrium squared. And that's going to be equal to x times x times x divided by, and we know the equilibrium concentration here, 0.067 squared. Now we just got to get the values of x. Well, we know that at equilibrium, 0.100 minus the amount that will be equal to 0.067 because we started with 0.1, 2x amount was consumed, and when that was done, we had this much left. That means we just got to solve for x. So we're going to have 0.1 minus 0.067 is equal to positive 2x. And when we finish the algebra, I'm not going to go through each little algebra step here. This is not an algebra class. We end up with basically 0.017. So we end up with Kc is equal to 0.017, supposed to be 17, times 0.017 over 0.067 squared. And I get my calculator out. 0.17 times 0.17 divided by 0.067 squared. And let's see here. And I think you get 0.25 for that if I did it right. Let me just check it one more time. 0.25 or so. Let me just double check. 0.017 times 0.017 divided by 0.067. No, I got 0.0. Okay. I'm having brain farts with my calculator here. I'm going to check it a third time. 0.064, right about thereabouts. Check one more time. Okay, so 0.017 times 0.017. 0.017 times 0.017 divided by 0.067 divided by 0.067. Okay, yeah, I think that's it. Okay, and that's how you do that. I hope that helps.